If today is Sunday, what day of the week will it be in 78 days' time? I said that if today is Sunday, in what day of the week will it be in 78 days? We can actually answer this question in a very simple way. But the idea behind this is modular arithmetic. Today is Sunday. Now, in 7 days, it's going to be Sunday again. In 14 days, it's going to be Sunday again. In 21 days, it's also going to be Sunday. For every multiple of 7, it's going to be Sunday. Okay? So, the multiple of 7 that is immediately less than 78 is actually 77. Because 7 times 11 is 78. It's 77. So, from 77 to 78 is just 1 day, right? So in 77 days, it's going to be Sunday again, while the 78th day, which is the day after the 77th day, it will be Monday. Now, the whole idea behind this is actually modular arithmetic. Today is Sunday. So at every 7 or in every 7 days, the day of the week will repeat itself, right? So that one is modulo 7 itself. So I want to determine 77 or 78 in modulo 7. The event I just described is represented like this in modular arithmetic. So if today is Sunday, it means that for every multiple of 7 is going to be Sunday. That 7 is the modulus. The operation is modulo 7. Understand it? This is modulo. All right. So what is modular arithmetic? So you're welcome back everyone to this video. We'll be talking about modular arithmetic. All right. What is modular arithmetic? Now this is the definition. Modular arithmetic is an operation actually which gives a remainder when an integer is divided by a fixed non-zero integer. I go again. Modular arithmetic is an operation, or is the operation which gives a remainder when an integer is divided by a fixed non-zero integer. So in modular arithmetic, we deal with remainders actually. It's just like in number basis. You know, digits under base 5 are from 0 to 4. The values that we have in base 10 are from 0 to 9. It means that 10 itself is not in base 10, right? 5 itself is not in base 5. We have positive numbers less than 5 down, positive numbers less than 10 in base 10. That's just it. So likewise, modular arithmetic. In modulo 7, integers under modulo 7 or in modulo 7 are from 0 to 6. That is it. It means that 78 is not a value in modulo 7 because 78 is bigger than 7. But there is a value that 78 is actually congruent to in modulo 7. I just said congruent, C-O-N-G-R-U-E-N-T. This is the word we use in modulo. We don't use equality. 78 is actually congruent to a value in modulo 7. What value is that? See how we work. 78 modulo 7 is this. If I divide 78 by 7, how many times will it go? 78 divided by the modulus, which is 7, it will go 11 times. Remaining what? Remaining 1. Because 7 times 11 is 77 plus 1. That will give me 78. So it is this remainder that I'm going to take. It therefore means that 78 is congruent to 1 modulo 7. That's just it. I could have as well written this. 78 modulo 7 is this. 78 is actually 7 times 11, which is 77 plus 1 or remainder 1. So what this means is that 78 is congruent to this one that is remaining under modulo 7. So 7 times 11 is 77. So I repeat that question again. If today is Sunday, in what day of the week will it be in 78 days time? What it means is that in 77 days time, or in 77 days, it's going to be Sunday again. So we just have one extra day left to make it 78 days. So if it will be Sunday in 77 days, one day after that Sunday, which is the remainder that we have, will be Monday. That's just it. So we count the remainder to determine what it will be. That's just all. So we are going to solve some problems now. Basic problems, algebraic problems, addition, subtraction, multiplication, division, and we'll solve equations involving modular arithmetic. All right, what is video to the end? Make sure you share this video to your friends, your classmates, and those people that you think would need this video. All right, let's proceed. Let's take this first question. What is 34 in modulo 5? Like I said, 34 is not an integer in modulo 5, so we have to reduce it and take the remainder. So if I divide 34 by 5, 34 divided by 5 is actually, how many times will 5 divide 34? 5 times 6 is 30. So that will be 6 times, remaining 4. So that 5 times 6, 30. 30 plus 4, 34. It means that 34 is congruent to 4 modulo 5. So in similar fashion, we could say that 6 modulo 9 is actually standard, right? Because 6 is a value or an integer modulo 9. It is not greater than 9, so we can leave it like this. 3. What will be 54 modulo 7? Of course, if I divide 54 by 7, let's see, 7 times 7 is 49, right? 50, 51, 52, 53, 54, remaining 5. So this is actually 54 is congruent to 5 modulo 7. All right, let's do something different now. How do we evaluate negative numbers in a modulo? Let's say we want to evaluate minus 11 modulo 2. It's quite easy, okay? See what we do. By standard, we are saying that the values in a modulo should be less than the modulus. Values in modulo 7, modulo 2 are less than 2, but they are not negative numbers. Yes, so we only take positive numbers that are less than 2. So they are just 0 and 1. That's the idea. So now we have negative value minus 11. What we'll do is this. I will look for the multiple of 2. This is the modulus 2. The multiple of the modulus, which is 2, that is immediately greater than 11, and then add it to minus 11. Multiples of 2 include 2, 4, 6, 8, 10, 12, 14, 16, 18, till infinity. From 12 downwards, they are all bigger than 11, right? But the multiple that is just immediately bigger than 11 is 12. So what I'll do is, I'll say minus 11 is congruent to minus 11, add the 12 to it, plus 12 modulo 2. So this is minus 11 is actually congruent to 12 minus 11 is 1 modulo 2. Full stop. Similarly, what will be 63? Okay, minus 63 now, modulo 4. Let's use modulo 4. Let me buttress the point again. I am looking for the multiple of 4 that is immediately greater than 63 that I will add to minus 63. so as to determine the value that is congruent to minus 63 in modulo 4. So multiples of 4, okay, let me just go down. I think 4 times 15 is 60, right? Yes. So we have 60. Then if I add 4 to this, that's 64. If I add 4 to this, that's 68. Add 4 to this, that will be 72, right? All of this, there are multiples of 4 before 60. Yes, 36, 40, 44, 48, 52, 56, 60, right? So I need the one that is just immediately bigger than minus 63, and it is actually 64. That's it. So what I'll do is add 64 to minus 63. So this will be minus 63 is congruent to minus 63 plus 64 modulo 4. So 64 minus 63 is 1. So we have minus 63 is congruent to 1 modulo 4. So we have 1 again, 1 modulo 4. It could be something else, depend on the number and the multiple. Okay, let's take some algebraic values. Question 6 now. What is 21x minus 18 modulo 4? Yes, what is this? By the way, this is how I'm going to explain it, okay? 21x is not in modulo 4, for the reason being that 21, which is the coefficient of x, is greater than 4. Yes. Actually, x is an integer in modulo 4. The reason is simply because the coefficient of x here, which is 1, is less than the modulus, which is 4. So we have 21 in this case, which is greater than 4. Okay, so it is not in modulo 4. So what is this? 21x. How many times will 4 go into 21? Let's forget about the x first. 4 will go into 21 5 times, remaining 1, because 4 times 5 is 20 plus 1, 21. So this is actually 4 times 5 plus 1, normally. So if I'm to add x to this, it means I will add x to this and add x to this. So that 4 will go into 21x 5x times, remaining 1x. You get the point now? Because 4 times 5x is 20x. 20x plus 1x is 21x. So 21x divided by 4 is actually 5x, remainder 1x. It therefore means that 21x modulo 4 is congruent to 1x modulo 4. So I'll be taking this remainder. Take note of it. Now let's come here. Minus 18 modulo 4. Minus 18. If I'm to evaluate minus 18 under modulo 4, I should be looking for the multiple of 4 that is just immediately greater than what? 18, and then add it to minus 18. The multiples of 4 are that is greater than 18 is actually from 20, 24, 28, 32. So I should be using 20, right? So if I say, if I add 20 to this, it will be minus 18 plus 20, and that will be 2. So this means that minus 18 is actually congruent to 2 under modulo 4. So the final answer, which is 21 minus 21x minus 18, will be congruent to 1x, which is x, plus 2 modulo 4. You understand it? That's just the point. It's as easy as this. Just so you know, some textbooks actually leave their answer in this form: x minus 18 modulo 4. Yes, they didn't simplify this. So we got x plus 2, and some resources will say x minus 18. This is also correct anyways. The thing is, we only simplified 21x here. We didn't break down the minus 18. Maybe they felt that minus 18 is actually less than 4. That is why they left it in this form. Like in the way they solved their question, they left the negative values like that. Both of them are the same, actually. Yes, they're the same. Question 7. 3x plus 6 plus 6x plus 2 modulo 7. If I add 3x plus 6x is 9x. 6 plus 2 is 8 actually, right? So this is 9x plus 8 modulo 7. Take note of this. A number in its own modulo 15 modulo 15. This is actually congruent to 0 in the same modulo 15. This is congruent to 0 modulo 7. So a number in its own modulo is 0, is congruent to 0 in the same modulo. That's for that. Now, for this, like I said earlier, 9x is not an integer in modulo 7, simply because the coefficient of x here, which is 9, is greater than 7, which is the modulus. So we have to reset this value into something that 9x is congruent to in modulo 7. If I divide 9x by 7, it will go 1 times, which is 1x time, remaining 2x. 9x is actually 7 times 1x plus 2x, because 7 times 1x is 7x, remainder 2x, which is plus 2x. So 9x modulo 7 is congruent to 2x modulo 7. I'll keep this. 8 modulo 7 is congruent to 1 modulo 7. You know that. If you divide 8 by 7, it's going to be 1 remaining 1, right? So everything here, let me just say 9x plus 8 is congruent to 2x plus 1. 2x plus 1 modulo 7. That's it for this question 7. Question 8 says, what is 3x? Okay, we've done that. 2x minus 1 multiplied by x plus 3 modulo 5. Modulo 5. Okay, let's go ahead. It's quite easy. If I expand that bracket, 2x times x is 2x squared. 2x times 3 is 6x. Minus 1 times x is minus x. Minus 1 times 3 is minus 3. All in modulo 5. So this is 2x squared. 6x minus x is 5x minus 3 modulo 5. Alright. Now take them one after the other. Take them 10 by 10. 2x squared. 2x squared. Is it an integer in modulo 5? Yes, it is. The reason is simply because 2 is a value under modulo 5. That's just it. After all, it is impossible to say, just like we said, 9x is equal to 7 times 1x plus 2x. It is impossible to say somehow that 2x squared is equal to 5 times something plus something, because 5 is already bigger than 2. You understand me now? So 2x squared modulo 5 is correct. Yes. So I will be leaving the 2x squared. So in the result, that is the value that will be congruent to this, 2x squared will still appear there. You understand me? Now, for 5x, 5x is not in modulo 5. We have to reset it, like determine the congruent value determine the expression that is congruent to 5x in modulo 5. Since 5 is an integer in modulo 5, if I reset it, it's going to be 0. See, 5x. What will I multiply by 5 to give me 5x? It's actually 1. 5 times 1x plus 0. because 5 times 1x is 5x plus nothing, 5x. So the remainder is 0. So for 5x, I'll be writing 0. Now let me just write, so I don't forget. 2x squared plus 5x minus 3 is congruent to, we said that 2x squared will still remain 2x squared. Then for 5x now, we are getting what? 0, which is nothing. So I can throw that away. Then let me come to minus 3 modulo 5. Of course, minus 3 modulo 5, we look for the value, the multiple of 5, the modulus, that is immediately greater than 3. Of course, it is 5. 5, 10, 15, 20. So we just use 5, since 5 is bigger than 3. So if I say minus 3 plus 5, that will give me 2. So minus 3 modulo 5 is actually congruent to 2 modulo 5. So, we got 0 here, and here we are getting 2. So I'll add this 2 modulo 5. This is the result. So 2x squared plus 5x minus 3 modulo 5 is congruent to 2x squared plus 2 modulo 5. Alright, don't forget to subscribe, don't forget to like, and don't forget to share this video to your friends and to your classmates. Question 9. Of course, you should know what this would be. 21 times 12 modulo 14. 21 times 12 modulo 14. Okay, if I multiply 21 by 12, that will be 252, right? Okay, so how many times this is actually equal to 252 modulo 14? So how many times will 252 with 14 going to 252 divided by 14? It's just, okay, exactly 18 times. So 252 is actually a multiple of 14. If I divide 252 by 14, is 18, remainder 0. So this is 25. 252 is actually congruent to 0 modulo 14. You get the point now? Alright, so let's proceed. 12 plus 24 plus 32. 12 plus 24 plus 32 modulo 15. Yes. 12 plus 24 is 36. 36 plus 32. 32 is 68, right? Yes, 68. So this is actually 68 modulo 15. Okay, before I write the modulo 15, I've already seen it that 68 is not an integer in modulo 15. So what is 68 congruent to in modulo 15? If I divide 68 by 15, that should be 4 times. 4 times 15 is 60. So if I add 8 to 60, that will be 68. So 68 is actually congruent to 8 modulo 15. That's it. Alright, let's enter division now. Don't forget to subscribe, don't forget to like, and don't forget to share this video to your friends, to your classmates, and to those that you feel they will need this video. Alright. What is 3 divided by 5? Question 11. 3 divided by 5 modulo 6. Of course, you know that if I divide 3 by 5, it will give me a decimal value, 0 point something, right? So we do not need decimal in this case. Yes, we don't. So we have to look for the value that is congruent to 3 divided by 5 in modulo 6. You know, I can write 3 divided by 5 as 3 over 5. So this is what we'll do. I will look for the multiple of 6, okay, any multiple of 6, that when I add to this 3, which is the dividend, the sum is exactly divisible by 5. Let me say it again. A multiple of 6. Multiples of 6 include 6 times 1, 6, 12, 18, 24, 30, 36, 42, and so on and so forth. So I will be testing which one of them will I add to 3, that when I add that multiple and 3 together, the sum can be divided by 5. Okay, let's see. I'll start 6 plus 3. That's 9, right? Of course, 9 cannot be divided by 5. I'll check the next one. 12 plus 3, what was it? 15. Yes, 15 can be divided by 5. Yes, it can. So this is simply 3 over 5 is congruent to 3 plus 12 over 5. In which mode now? Mode 6. 3 plus 12 is what? 15, right? 15 divided by 5 is 3. So it means that 3 divided by 5 is congruent to 3 modulo 6. That's it. Question 12. Let us do 6 divided by 5 modulo 7. In similar fashion, this is 6 over 5 modulo 7. So we are looking for the multiple of 7 that will be added to 16 to 6, such that the sum of that result is exactly divisible by 5. Multiples of 7 include 7, 14, 21, 28, and so on and so forth. So which of these multiple of 7 will I add to 6 so that the sum is exactly divisible by 5? 7 plus 6, that's 13, of course. 13 cannot be divided by 5. 14 plus 6, 20. Good. I can divide 20 by 5 and the result is 4. So I'll be saying 6 over 5. Okay, 6 over 5 is congruent to 6 plus 14 over 5 modulo 7. And this means that 6 plus 14 is 20 divided by 5. That's 4. So we have this as 4 modulo 7. How do I solve this? 3 plus x congruent to 4 modulo 5. It's easy. I'll solve it like an equation. X is here. It will be congruent to 4. 3 will cross turn to a minus modulo 5. 4 minus 3 is 1. So x is congruent to 1 modulo 5. That's it. Similarly, what will be x squared plus 1 equal to 2 modulo 7. X squared plus 1, okay, congruent to 2 modulo 7. I should solve this like an equation. If I solve this equation, x squared plus 1 equal to 2, it means that, okay, fine. X squared will be congruent to 2 minus 1 modulo 7. X squared will be congruent to 1 modulo 7. So if I take the square root of both sides to eliminate that square, so s will be congruent to plus or minus 1 modulo 7. You know that the square root of 1 is plus or minus 1. So 1, this is s is congruent to 1 modulo 7. This is one answer. Then the second answer is s is congruent to minus 1 modulo 7. But you know that minus 1 is actually not an integer in modulo 7. Take note, this can be the answer. It is correct. But that's in the case where we have to combine the two solutions into one using plus or minus. We can take this. But if they split the solution into 2 without plus or minus, then we have to simplify further. Of course, you know that minus 1 is not in modulo 7. So what I'll do is to reset minus 1 by adding the multiple of 7 that is immediately greater than 1 to minus 1. And that multiple will be 7 itself because 7 is bigger than 1. So this will be minus 1 plus 7 modulo 7. And that is actually 6 modulo 7. 6 mod 7. So we can say that s is congruent to plus or minus 1 modulo 7, or s is congruent to 1 or 6, 1 and 6 modulo 7. You understand now? So this could also be the solution. This can be the solution or this as well. This is how far I will go in this video. I hope you enjoyed the video. Don't forget to subscribe, don't forget to like, and don't forget to share this video to your friends and to your classmates. Okay, I am the complex analyzer, and I will see you in the next video. Just keep watching.